All right, get ready, because today we're really diving into AI.
Yeah, like really getting into it.
Exactly, like specifically GPT language models.
The stuff that powers ChatGPT, right?
Yeah, have you ever wondered how those things actually work? Like what's going on under the hood?
The cool thing is, um, for this deep dive, you've actually given us a guide to building one.
Oh, that's right. So it's like we're going to become like AI architects,
Yeah.
building a language model from scratch.
And your source material, it even starts with this, it uses this tiny Shakespeare example.
Tiny Shakespeare.
Yeah.
So we're going to build an AI that can like write like Shakespeare.
Yeah, it's kind of a fun way to like illustrate it.
That's awesome, but why start small? Wouldn't it be more impressive to build a GPT that can like, I don't know, analyze the entire internet?
Well, so think of it this way.
Okay.
We're like learning to bake a cake,
Right.
and we want to understand every ingredient and how they work together.
Okay.
Tiny Shakespeare gives us that kind of manageable starting point.
Okay.
We can grasp the core principles without being overwhelmed by just this mountain of data.
Okay, yeah, that makes sense. That makes sense.
Yeah.
So where do we begin? Where does our AI journey begin?
Well, every language model, it needs a vocabulary.
Okay.
But we're not just talking about like a list of words, right?
Yeah, yeah.
Imagine we're breaking down Shakespeare's works into their like tiniest parts. Every letter, every punctuation mark, even the difference between like an uppercase and lowercase letter.
Oh, wow.
All that, those are all part of our AI's vocabulary.
It's like we're creating like a unique fingerprint for every single character in all of Shakespeare.
Exactly. And just like fingerprints help us identify individuals, these unique codes help our model identify and understand like the building blocks of language.
Okay.
But we can't just throw letters at our model and expect it to write sonnets.
Right, right.
We need to turn those letters and symbols into something a computer can actually process.
Okay, so numbers.
And numbers, exactly.
Computers love crunching numbers.
Yeah, that's their thing.
So how do we make that leap? How do we go from like Shakespearean English to like AI-friendly digits?
Right, and that's where tokenization comes in.
Tokenization.
Yes, it's like translating each of those fingerprints that we talked about into a numerical code.
Okay.
Each unique character gets its own special number.
So tokenization is like giving our AI a secret decoder ring to unlock the language?
Exactly. Now our AI can start to like read and process Shakespeare's works, right?
Right.
It can start to see patterns and relationships within those numerical codes.
Gotcha. Okay, so we've got our vocabulary set, and we've got all this text converted into like ones and zeros, basically, or well, numbers.
Right.
What's next? Do we just like feed our AI the complete works of Shakespeare in one go?
Not quite.
Okay.
Just like a good actor needs rehearsals, our model needs training.
Okay.
So we divide our tiny Shakespeare data set into two parts, one for training and one for validation.
So like a dress rehearsal.
Yeah. Yeah, right.
Practice and then see if it can actually perform.
Exactly.
Okay.
The training data is the script. That's the lines our AI will study and learn from. The validation data is the performance, where we see if our AI can improvise and generate new text in Shakespeare's style.
Gotcha. Okay.
Yeah.
This is really starting to sound like we're like putting on a play here, directing a play.
It is. It's a good analogy.
Yeah. But even with tiny Shakespeare, we're still talking about a lot of text.
We are, yeah.
How do we make sure our AI doesn't get like overwhelmed during rehearsals?
Right, and that's where chunking comes in.
Chunking, okay.
Yeah, so imagine breaking down a long Shakespearean play into like individual scenes or acts.
Okay.
Instead of feeding the entire play to our model at once, we break it down into these manageable chunks of text.
Okay, so bite-sized pieces.
Yeah.
Easier to digest, even for an AI.
It helps the model focus on the relationships between words within each chunk, understanding how each word influences the next bit.
Okay, so it sees how one word leads to the next.
Exactly.
But it's not just about individual scenes, right? It's also about the bigger picture.
That is, yeah.
So how do we make sure our AI understands the entire play, not just these like isolated scenes?
That's where batching comes in.
Batching.
Yeah. So instead of training the model on one chunk at a time, we group multiple chunks into these batches.
Okay.
It's like having different groups of actors rehearse different scenes simultaneously.
So it's getting a taste of everything at once.
Exactly. This helps the model see a wider range of language and context, making it a more versatile learner.
Okay, so to recap, we've created a vocabulary, we've translated it into numerical code, we've split our data, we've chopped it up into like these different scenes, and now we're rehearsing those scenes with multiple acting troupes.
Yeah. We're getting there. We're getting there.
That's awesome. But I have a feeling we're just getting started, right?
We're just warming up.
Okay.
Yeah, now that we have our data prepped and ready, it's time to start building the stage itself, the model architecture.
Ooh, okay.
And we're going to start with something surprisingly simple, the Bigram language model.
Big room. Okay.
Yeah.
That sounds kind of
Yeah,
mysterious.
it's a good one.
What is that? Bigram language model. It's like the opening act of our AI play, right?
Yeah.
Setting the stage for something much bigger.
Exactly. Think of the Bigram model as like our understudy,
Okay.
learning the basics of language prediction.
Okay.
It's a simple model that looks only at the previous token to predict the next one.
So if our AI encountered the word like Romeo, the Bigram model would try to predict the next word just based on Romeo.
Exactly.
That seems kind of limiting.
It is. But I mean, even Shakespeare had to learn the alphabet before he wrote Hamlet, right?
That's true. That's true.
Yeah. So this Bigram model helps us understand that fundamental mechanism of like predicting sequences of text.
Okay. All right. I'm intrigued. I'm intrigued.
Yeah.
So how does this understudy actually function? What's going on?
So just like each character in a Shakespearean play has like a unique personality.
Right.
Our Bigram model uses what are called token embeddings to give each character in our vocabulary its own set of numerical features.
Okay.
It's like giving each character a unique costume so our AI can easily like distinguish them.
So instead of just seeing numbers, it starts to see characters with their own like identities.
Exactly. Now for the actual like prediction process, we use what's called a forward pass.
Okay.
Our model takes the embedding of the current token, say Romeo,
Okay.
and based on that, it tries to predict the most likely next token.
So it's like our AI is trying to guess what Romeo will say next based on like his personality and like what's happened in the scene so far.
Exactly.
But how does it know if its guess is any good? Is there like an AI critic in the audience that gives it like a thumbs up or a thumbs down?
Yeah, you could say that. We use a measure called cross-entropy loss to evaluate the model's predictions.
Cross entropy loss. Okay.
And the lower the loss, the more accurate our AI is in predicting the next token.
So if the loss is low, our AI is getting a standing ovation for its Shakespearean performance.
Exactly.
Yeah.
And remember, our Bigram model is still like in its early stages of training here.
Okay, right.
It might not be winning any awards for its writing just yet.
So we need to give it like some serious acting lessons if we want to go beyond like these basic predictions.
We do.
Yeah.
Yeah, that's where things get really exciting.
Okay.
We introduce what's called the attention mechanism.
Ooh, attention mechanism.
Yeah, and this is where our AI goes from just like reciting lines to truly understanding the nuances of Shakespearean dialogue.
Okay. Okay.
Like really getting it.
Okay, so attention mechanism. What makes it so special? What is it?
Imagine if each word in a sentence could like focus on all the other words
Okay.
and figure out which one's the most important for like understanding the overall meaning.
Okay.
That's essentially what the attention mechanism allows our AI to do.
So instead of just focusing on the previous word like our Bigram model was doing, right?
Now our AI can analyze like the whole scene.
Exactly.
Yeah.
It's like giving our AI the ability to understand like not just individual words, but the relationships and connections between them.
Okay, yeah. I can already see how this is a game changer.
Yeah, for sure.
But how does it work? Like, how does our AI know which words deserve the spotlight?
So within the attention mechanism, each word is transformed into 3 vectors: a query, a key, and a value.
Queries, keys, values. It's starting to sound like a treasure hunt inside of our Shakespearean play.
I like it. I like that analogy.
Yeah.
Think of it this way. The query is like the word asking. You know, like what information am I looking for from the other words?
Okay.
The keys are like the other words saying, here's what I have to offer.
Okay.
And the value is the actual information or insight that each word holds. So it's like every single word is having a conversation with all the other words, trying to figure out what's important.
Exactly. And the model figures out which words are most relevant to each other based on these queries, keys, and values.
Okay.
And then it uses those connections to create a more nuanced understanding of the text.
So it's like our AI is no longer just reading the script. It's
Right.
like analyzing the character's motivations and the subtext and like the entire dramatic arc.
Yeah, exactly.
Oh, okay.
And there's one more like crucial aspect of the attention mechanism,
Mm.
masking.
Masking.
Yeah.
Yeah.
We have to make sure our AI understands the flow of the play, that it doesn't like jump ahead and spoil the ending.
Right. No spoilers allowed.
Exactly. So masking ensures that our AI focuses on the words in the correct order, just like, the plot of a play unfolds scene by scene.
Scene by scene. Yep. Okay. So masking keeps everything in order.
It does.
Okay, so now we've equipped our AI with ability to like focus on the most important words and understand their relationships.
We have.
That's awesome. It's like our AI has graduated from acting school and it's ready for like the big leagues,
It is.
but we still need to build the actual theater, right?
We do.
The
The architecture.
the architecture, yeah, that
Yeah.
houses all this incredible AI power.
You're right on cue.
Okay.
That's where the transformer architecture comes in.
The transformer.
Yeah, and it's this like ingenious design that takes everything we've discussed, tokenization, embeddings, the attention mechanism,
Okay.
and combines them into this like powerful language model.
Okay, I'm ready. I'm ready for the grand reveal. What makes the transformer so special? All right, let's talk about this transformer. What's it all about?
It's like, uh, the Globe Theater.
Okay.
It's like that for our AI world.
Okay.
This magnificent structure where we get to see the full potential of our language model.
I like it. So what are the kind of key elements architecturally that make the transformer special?
So one of the most important things is this thing called multi-head attention.
Multi-head attention. Okay.
Yeah, imagine if we have all these different groups of actors
Okay.
and they're each focusing on a different aspect of a scene.
Yeah.
Like the dialogue, the stage directions, the like emotional undertones.
Okay.
It's kind of what multi-head attention lets our model do.
So it's like our AI is getting multiple perspectives on the same like text.
Exactly.
Yeah.
Each attention head can focus on like different relationships and connections within the text, and that creates just like a much richer understanding of the language.
So it's not just about analyzing the text, it's about analyzing like how it's all fitting together.
Exactly. Yeah.
Okay, that makes sense.
Yeah, and it's not just about analyzing from different angles.
Yeah.
It's also about processing all that information effectively.
Right, because I imagine too many cooks in the kitchen, that can be a problem.
It can. It can.
So how do we make sure that the transformer is handling all these different attention heads without getting, lost in the weeds?
Right. So that's where the feed forward layer comes in.
Feed forward layer.
Yeah. So after each word has been analyzed by that multi-head attention,
Okay.
it gets its own moment in the spotlight. Think of it as each word getting to deliver its own soliloquy,
Okay.
reflecting on the insights it's gained from the other words.
I love it. It's like each word is internalizing its role in, the grand scheme of the play.
I like it.
Yeah. So what happens next? What happens after kind of this internal reflection?
So as our AI is processing more and more text, we have to make sure that it remembers like the important information.
Okay.
And that's where residual connections come in.
Visual connections.
Yeah, these are like they're like clever shortcuts within the model's architecture,
Okay.
and it allows the model to kind of recall earlier insights.
So it's learning, but it's also remembering what it learned.
Yeah, exactly.
Okay,
Exactly.
that makes sense.
And then finally,
Okay.
to make sure this whole process runs smoothly, especially as our model gets more complex, we have something called layer normalization.
Layer normalization. Okay.
Yeah, think of it as like the stage manager of our AI theater,
Okay.
making sure all the elements are like balanced and working in harmony.
So everything's running smoothly backstage.
Exactly.
Love it. So it sounds like we've built this incredible AI theater.
We have.
But, I know from our past deep dives that sometimes like bigger is better.
It is.
Can we scale up this transformer? Can we make it even more powerful?
Absolutely, yeah. Scaling up a transformer is like building a bigger theater, right?
Okay.
With a larger stage, a bigger cast, more elaborate sets and costumes.
Okay, I like it. I like it. So how do we do that with a transformer?
So we can achieve this by increasing the number of layers, attention heads, and the size of our token embeddings.
Okay, so break it down for me. More
Yeah.
layers. So that's pretty intuitive, right? Like more scenes to the play.
Exactly.
More depth, more complexity.
Okay, and then increasing the number of attention heads.
You okay?
That's like hiring more assistant directors,
Well,
each with their own area of expertise.
so we've got like the head of dialogue and then we've got the head of like, I don't know, stage combat or whatever.
Exactly. Yeah, and this allows the model to capture like even subtler nuances and relationships within the text.
Okay, and then increasing the embedding size, that's like giving the actors those really fancy costumes.
Exactly. A larger embedding size allows for more nuanced representations of words.
Okay.
It can capture like a wider range of meanings and contexts.
So by scaling up these three things, it's like we're giving our AI a much more powerful lens through which to view, all of language.
Exactly.
Okay, that makes sense. But I imagine there are challenges with like scaling, right? Just like building a bigger theater is more
Yeah.
complicated.
For sure, one of the biggest challenges is this risk of overfitting.
Overshit?
Yeah. It's like an actor who's just memorized their lines perfectly,
Okay.
but can't improvise or adapt to any changes in the script.
They're so focused on just like the specifics they've missed, like the bigger picture.
Exactly.
Okay.
To avoid overfitting, we use a technique called dropout.
Dropout. Okay.
Yeah, and this might sound kind of counterintuitive,
Okay.
but during training, we randomly drop out some of the connections within the model.
So we're intentionally like limiting what it can learn at any given time.
In a way, yeah.
Okay.
So think of it this way.
Okay.
By forcing the model to rely on different pathways and connections,
Okay.
we prevent it from getting like overly reliant on any single piece of information.
So it's like we're making all the different actors like rehearse different versions of the scene.
Exactly, yeah. So they're ready for anything.
I like it. So dropout helps our AI become more versatile.
Exactly.
Okay, that makes sense. That makes sense. So we've built our stage, our AI stage.
We have.
We
Jacob.
trained our actors, and we've got like these quality control measures in place to prevent like stage fright.
Stage fright, yeah.
I love it. So the moment of truth has arrived.
Yeah.
Can our AI actually write like Shakespeare?
Let's find out. Expert speaker reads passage of AI-generated text.
That's really good.
Right.
It's not perfect Shakespeare, obviously.
Of course.
But the language is there.
It's there.
The rhythm, the like dramatic flair, it's all there.
And to think, like, it got this just from recognizing these patterns.
Yeah.
Analyzing relationships between words.
It's really incredible. It makes you really appreciate like how powerful these language models are.
Yeah, for sure. For sure.
Well, this has been an awesome deep dive
It is.
into GPT language models.
Yeah.
Really fascinating stuff.
It is really interesting to see how it all works.
Yeah, thanks for breaking it down for me.
Yeah, of course.
And for everyone listening, we hope you learned something new today.
Absolutely, yeah. And keep seeking knowledge.
Until next time.